the capability to obtain vertical profiles of temperature and moisture throughout the various layers of the atmosphere. In 1994, GOES-I was launched, and with it came significant improvements in the resolution, quantity, and continuity of GOES imagery and data, thanks to a new 3-axis method of stabilization. Once it reached orbit, it was renamed GOES-8 and gave forecasters more accurate information to pinpoint locations of storms, wildfires, and other hazards. By the mid-2000s, GOES-N, GOES-O, and GOES-P further improved the imager and sounder resolution to better pinpoint the locations of intense storms. This satellite series also had improved optics, better batteries, and more power, allowing for more continuous imaging.
3, 2, 1.
Then in 2016, the current generation of geostationary satellites was launched, the GOES-R series. With this series came new advancements that included state-of-the-art instruments like the Geostationary Lightning Mapper and the Advanced Baseline Imager, or ABI. For nearly 50 years, the GOES satellites have provided a unique view of Earth. As the program advanced, so did the technology, allowing it to become the most sophisticated weather-observing, environmental monitoring, and space weather monitoring satellite system that helps promote and protect the nation's security, environment, economy, and quality of life.
With the help of GOES data, NOAA weather forecasters predict above normal hurricane activity in the Atlantic Basin this year, with 17 to 25 total named storms, including 4 to 7 major hurricanes with winds of 111 miles per hour or higher. GOES satellites help predict the severity and the path of these devastating storms, and here's how.
So the polar orbiting satellites complement the geostationary. Since the geostationary, like 24,000 miles up, while they get great pictures, it's really hard to measure what is the state of the atmosphere from that distance. So the polar orbiting are basically flying a little over 500 miles up. And when you're at that altitude, you can sense what's in the atmosphere to a lot higher resolution.
Two things people always want to know about hurricanes are how strong is it and where's it going to hit. And microwave sounders can certainly help with both of those. The ability to see through clouds becomes really important. If you've ever seen a picture of a hurricane from space, mostly what you're seeing is clouds. And you can get a better weather forecast, a better prediction of how strong the hurricane is and where it's going to hit, which direction it's going to go, if you could see through those clouds and see the structure of the atmosphere, maybe even the ocean conditions underneath that. And so microwave sensors allow you to do that kind of thing.
You'd like that as precise as you can, so that only the people who are really going to be affected have to do something. The improved sensors that we've been flying allow a better understanding of the core of that hurricane and allow the forecasters to better predict precisely where that hurricane is going to hit. And when they do that, then you can narrow and shrink that cone of uncertainty and give a better prediction.
We hope to continue to improve the ability to do track forecasting. That's gotten so much better over the past couple of decades. Our 5-day forecast is about as accurate as our 2-day forecast was only about 20 years ago.
And increasingly, people are listening to the forecasts that they get from meteorologists. They have increased confidence. They see the improvement in forecasts as it relates to hurricanes over the last couple of decades. And when a hurricane watch or hurricane warning goes into effect, people take notice and they take action. And that's really encouraging to see.
Data from weather satellites is one way NOAA tracks severe weather, but as they have other tools, they use them. And it's not a tool, but he's our guest. That was kind of a weird read there. Joining us now is Nick Underwood. He is the agency's hurricane hunter. Not a tool, a hunter. Great to have you here. What is a hurricane hunter? I mean, it sounds pretty cool.
So hurricane hunters, we operate 3 of NOAA's aircraft, 2 WP-3D Orions and 1 Gulfstream 4. And we use these aircraft to fly into and around hurricanes to collect what we call in situ data. So actually sampling the atmosphere and the ocean in and around hurricanes so that the forecasters at the National Hurricane Center can have a clearer picture of how the storm is developing and how it's moving.
So what is inside a hurricane that we need to know that we can't get from other instruments?
It's that in situ data. It's the pressures, the temperatures, the humidities, the wind speed, the wind direction, the ocean sea surface temperature. All of this data we're able to collect with our aircraft as well as some of the instruments that we have on board. And all of that is vital for the forecasters.
All right, you've got some amazing video that you shared with us flying in a hurricane. We want to play that now, and you kind of talk to us about what it's like to fly inside a hurricane with 150 mile per hour winds.
So this video is from our WP-3D Orion. That's actually flying through Hurricane Florence in 2018. And on the P3, it's kind of like being on a wooden roller coaster that's inside of an automatic car wash. So a lot of vibration, a lot of getting bounced around, wind and rain slapping against the windows.
There you are.
It can certainly be a bumpy ride, yes. Our Gulfstream 4 flies up above, around, and in front of the storm to sample the high altitude atmosphere, usually at 45,000 feet. And all of this data feeds into those forecasts that you see on TV of the spaghetti plots of all the different ways a storm can go. And the better data we can collect up in the air, the more accurate those forecasts are going to be.
Right there, are you like catching some air right there? Looks like the bottom dropped out.
Yes, absolutely. You can get lightning a lot in these storms. You can certainly get some hefty bumps, a lot of turbulence, but it's exciting work and it's important work.
And we saw the G4 here today at the shuttle landing strip.
That's right. A lot of people got to check it out. You have one more tool that that you use, and that is a drone. I didn't even realize that we have a drone that's going to come flying in. Watch how this thing flies right into the set. See this? Thank you, John. Appreciate that. From
there we go. Perfect.
In there. I didn't realize that you guys had tools like this. What do you do with this?
So this is newer technology. We've been launching these out of our P3 Orion the last couple of years, and so these are able to get down to altitudes that we can't safely get to in our aircraft. When we're flying through a hurricane, we won't fly below 5,000 feet, but these can get down to as low as 30 feet off of the ocean surface into what we call the boundary layer. That's where the ocean and the atmosphere are really interacting. It's where all of that energy is really flowing up into the storm, and so this can get us high resolution data at really low altitudes that we really can't get any other way.
How do they hold up? I mean, these are the most violent storms on Earth, and how does this guy do?
So typically these we'll drop these in the eye where it's calmer. They can work their way into the eye wall, and when they do that, they tend to just follow the wind. So they're not trying to fight against the storm, they're just going with it.
I was about to say, I mean, that's amazing that they can hang in there for that long to get back data. You're a former, well, you're still a meteorologist. Do you recall using data like this, and how would you work it into a forecast?
Oh, anytime there's a landfall hurricane coming towards the U.S., we have the hurricane hunters up 24/7. We're tracking every observation, every pass. They're seeing the real-time changes, right? There's no other way to get it.
Absolutely.
So what's the craziest hurricane hunting story you can tell us, Nick?
2 years ago, into Hurricane Ian, as it was working its way towards the coast of Florida.
Cat 5 at one point?
We were flying through at the point when it briefly intensified to Category 5. Wow. We were in the eye wall for what was 10 minutes, made it into the eye, were able to mark the center, launch a drone into the eye of the storm, work our way back out. That flight was the bumpiest I've been on in the 8 years that I've been doing this.
What about the lightning? Could you see it while you were in the eye wall?
Lots of lightning. I think there were over like 1,000 lightning strikes in the eye wall over the course of a couple hours there. It was a night mission, so you could really see it flashing. It was very impressive.
Lightning flashing every second, being blown all around in a plane, and how did you feel?
It was certainly one of the more tense missions that we've been on, but all of our crews are highly trained. Everyone on that aircraft is focused on doing the mission, doing it well, making sure that we're gathering the data safely and that we're doing it effectively.
Nick Underwood, Hurricane Hunter with NOAA. It was great having you here. Thanks for sharing your stories. Not as cool as a bounty hunter, but Hurricane Hunter, I mean, what's bigger than a hurricane, right? Yeah, that's great. Thank you very much, Nick.
Thank you.
Appreciate it. Well, back to talking weather satellites. GOES-U is the last of a generation that began with GOES-R. The next generation of NOAA's weather satellites will be GeoXO, or Geostationary Extended Observation. Here's more.
Like GOES-R, GeoXO will